Thank you for joining. Today we're going to talk about how video streaming is working, and of course, how can you use it. I'll explain the complete end-to-end flow from the camera till it gets to your device, and we'll talk about some engineering challenges that we have there. But first of all, let's start with the basic. So first of all, did you ever wonder what it takes to broadcast, for example, a live soccer game glass to glass? And when I say glass to glass, it's mean from the camera till your mobile phone without any delays, buffers, okay? When you watch a soccer game, you don't want to get this experience right before the goal. You will get the spinner. You don't know if Messi able to score it or not. But of course, for the ones who love Messi, so let's
Autorizar a cobrança de falta pé esquerdo.
this was a goal.
Autorizar a...
So hi, I'm Itay, father of three and married to more. For the last 10 years, I'm working for Kaltura, and I want to share with you today how video streaming is working and how you can actually help you in your next video challenge. So a little bit about Kaltura. Kaltura mission is to power any video experience, okay, for any organization. We have more than 600 employees, many customers, 3 development centers, also in Minsk. We have many customers from a wide variety of verticals. I guess you know some of them. And our solution includes video portals, live events, TV solution like Netflix in the box and more. And we also have a nice developer side, which I'll show you, and open API so you can use. So this is a little bit about Kaltura. And now let's talk about video. If you have any questions, please ask them in English so I can see them. And we have a moderator, so if you need to stop and explain something, just let me know. Okay, so it's all start from the camera. Okay, the camera is the first glass produce ultra high resolution of video, usually not compressed. Okay, if we talk about, let's continue with the soccer game example. And let's say, for example, the camera produce HD video with 60 frames per second, and if you do the math, okay, without any compression and everything, we're getting into 3 gigabits of data flow. Okay, now in where I live, okay, I have around between 40 to 300 megabit of internet to my house. So of course we can't consume this video directly, right? It needs to go some modification. Okay, so the first station is the control room. Okay, the control room is actually where you get multiple streams of non-compressed video and then gather into one stream, okay, with additional metadata like caption or more audio tracks that you want to add to your video. And then when the control room actually reproduces one stream, then it goes into a transcoder. Okay, transcoder can be on premise or on the cloud. The transcoder main job is to change from raw data, okay, from raw video into compressed video, okay, but compressed video, like a smart compression that will not hurt dramatically on the quality, and it will be possible, at your mobile phone or at your TV at home to consume this video with your internet connection. The compression is being made by a few smart algorithms. Okay, these algorithms called codecs in the video world. Okay, we have a few of them. So if you heard about H.264, which is AVC, H.265, which is high efficient video codec, VP9, AV1, and more. Okay, we have many more, but these are the famous ones. And what they do is like magics. Okay, let's call it a magic right now. But this is a really interesting field. If you're interested on it, there's a lot of reading stuff over the internet. What they actually do is compressing the video in a smart way. Okay, like video is actually compressing. Video is like compressing image, but just with the time vector. So each image, okay, we have usually like an iframe, which is a complete image of the video. This compression is done by like you compress images. You divide it into a section. You find a template and compress them. And on the video, what is also interesting is that you have the moving part, right? So you don't need to update everything on each frame. You can just update what changed, okay? And also what changed, it can be compared to the previous image frame or the after, like the future frame, okay? Video, you decode by chunks, so you can look also forward and also backward. Okay, after that, okay, after we compress the video and usually transcode it or convert it into a different codec. Okay, codec again is the algorithm that's being used for compression. And also when you get to your device, it will need to do some decompression, okay, like extraction using usually hardware, okay, usually your GPU already have this algorithm inside and know how to decompress it and show it to the screen. After that, we have the we actually produce a few rendition of the video, okay, because this video need to get also to big screen and also to your mobile phone, and we package it. Package it meaning we actually divide it into small chunks, okay, between 1 to 10 seconds. It can be even more, it can be less. If it all depends on the latency you want to see. And it's packaged into a protocol that your phone or TV know how to read. And we'll talk about it. Okay, but in general, this is the end-to-end flow, from the camera to your device to get the video and make sure it will play nicely without any buffers and all. Now I want to talk about a little bit what is happening on the device itself. And when I say device, it can be your desktop that you are watching now the video. It can be your mobile phone. It can be the TV. Everything that play video from the internet. So there are a few ways to play video. I will start with the naive one, what you probably all know, like a progressive download. You have like an MP4 file on the server and you want to start play it. When you package, we create the MP4 file, usually we put the index in the beginning. So the first download, we already know, the player already know where we need to go in the file in order to get, like, for example, second 20 or minute 40 or stuff like that. And the player actually start downloading chunk by chunk, play, and continue to buffer forward to make sure you will get the nice experience. And the main advantages for this protocol, okay, is it's very simple. All, if not most of the devices support it, meaning if you just give, the video tag or the iPhone or the Android MP4 file, it will know how to play, okay? But let's talk a little bit what are the disadvantages of using this protocol. So first one is, we have only one file, okay? It can be like the highest resolution, mid resolution, but it's not fit to all screen, meaning if you take, for example, a 4K or HD content, okay, and try to play it on your old Android device or even new Android device, it will probably play it, but it will consume a lot of battery power, a lot of network, and it's not optimized. On the other hand, if you take a small file and try to play it on a big screen TV, you will see like the bad quality, like the boxes and everything, because it's not the right file for this device. Okay. So what can we do? We can actually create a single file for each of the resolution we want. Okay. Meaning, if we are now watching from TV, we will get the high resolution. If we are watching from the desktop, we can get the mid resolution and stuff like that. The problem with that is that this system is not adaptive to the bandwidth, okay, the internet bandwidth we have. You know that when you drive, you use your 4G or 5G, or even at home sometimes, we have some issues with the internet, and we need to make sure the user will keep watching the video, okay? So when you have like a slow connection, you should adapt, okay, to the speed, and maybe watch for some minutes or for some second lower resolution, and then go back to the original resolution. And it's all a game, you know, how to buffer and how to get the stream. So HTTP streaming, okay, compared to the progressive download. First of all, it's multi-bit rate, and I'll show it. It's adaptive, okay, it's adaptive both to your screen size and to the network condition. You can stream with it live and VOD, video on demand. And if you heard about HLS, which is HTTP live streaming, this is a Apple standard. So usually on your iPhone and on Apple TV, you watch HLS stream, and also usually on the web. We have HDS, which is HTTP dynamic stream, which is something a little bit old. Smooth streaming, which is Microsoft also, and was replaced by Dash, which is also a standard of plain HTTP streaming. Okay. The main thing is here is that the client should need to be smart. Okay. Everything usually is cached on the CDNs, and I'll show it. But the client need to decide, meaning the player, okay, need to decide which content he want to play, which resolution, what need to be consumed, how much to buffer, how much to take, and all of that. So how it actually works, and maybe I'll show a live example on that, but we have a file, okay, MTU8, usually if we talk about HLS, which have links to multiple renditions, okay, multiple rendition mean like the resolution and the frame per second and all of that, and how much bandwidth I need in order to consume it. And these links actually take us into a list of chunks that we can play. Okay, we can download and play. How it's looked. So if you start, you know, from lower resolution, and then on the next chunk you can get to higher resolution because the network is fine, and then you keep going up. But if you have some issues with the network, you go down again. Okay, just to make sure we will not hit any buffer issues and stuff like that. If we take a look how it looks like in the network, you can see my screen. Yes. So if I go, for example, to Apple site and see example of HLS stream, and when I say HLS stream, so Safari know how to play it out of the box, and you can see it here, just a video tag with link to MTU8 file, and how it looks on the network side. So when we get the MTU8, we get like a manifest file, which tell us, for example, if you want to play this codec, which is H.264, this resolution, this frame per second, okay, you should go to this file, okay, V5, V9, and everything. If you want to play, for example, HEVC content, which is this type of files, you should go to this file, okay. And also we have information here about captions and audio tracks, which is here. And then when you actually go to the file, what you get is actually a list of segments. Okay, each segment here is 7.5 seconds. Okay, which the browser or the player here keep on downloading and downloading by that order. So this is how HTTP streaming works. Okay, in HLS we have the manifest request and then the playlist. Okay, the what we actually need to play. Of course, there is a few more information here. And if, for example, it's a live content, this file will keep getting update and update again. Great. So this is how HTTP streaming works over internet. And now I want to talk with you a little bit what can you do with it and how you should treat it. And let's start first of all with security. So ways you have in order to secure the stream. Okay, and and we'll talk. So the first one, of course, is encryption, tokenization, and we'll talk about each one of them. Watermarking, which is something you do usually for more premium streams, and DRM, digital right management, which is also something you do for premium streams. So let's start with the basic encryption. Okay. So first of all, you need to make sure that you use HTTPS, so to make sure the delivery will be encrypted. And also there is a way to make sure each of the chunks will be encrypted using some key. HLS has its own way, and also other streaming protocol. And it's supported out of the box by all HLS players. Okay. Tokenization is usually something you get from your CDN, your content distribution network, like Akamai or Amazon, CloudFront. This is actually a way for the CDN to sign on the URL, okay, with a specific token. You exchange, of course, secret with your CDN, and then you can sign the CDN actually sign the URL with, for example, the user IP or his device or and anything, and you can configure anything you want. You can also use cookie, for that. And then it's actually one-time URL, okay, with expiration. You can control the expiration, and only the users that request this URL can get the video, the content. If you pass it to someone else, in theory, it will get different IP or something like that, and he won't be able to watch it. Watermarking, which is something used usually for premium content, is you actually, each stream has its own signature with unique watermarking, okay, that user usually can't see, but this is like a forensic watermarking, and it's specific to the user that is getting that, okay? So if the stream is, going to some other networks, or you share the stream, someone can come and see from where this stream leaked. Okay, it can be user ID or a company that bought it or something like that. And yeah, it's easy to find with distributed content. And lastly, we have the DRM, the Digital Rights Management System. And this is something that's actually very popular, in the videos that we see today. The stream is actually encrypted using a key, of course. The key is approved only for a license request using secure stream. Okay, so the DRM system is actually a way to pass the key to the user in a secure way. Okay, and who is actually doing this secure way? Usually the DRM provider, and we'll talk about it. The decryption and delivery is done by a secure hardware channel. Okay, so all of your phones, Android, iOS, has hardware chip, that's responsible for it. On Apple, it's called FairPlay. On Google or Android, it's called Widevine, and Microsoft is PlayReady. Okay, Microsoft is, for example, for Xbox and Edge browser. Google is for Chrome and Android, and Chromecast and Android TV, of course. and Apple TV and iOS devices is FairPlay. And they actually give companies like us the way to move the key to send the key to the client in a secure way. And then the decryption and the way to the screen is actually secured by the manufacturer. How it's actually works, let's see. So first phase, of course, when you have the source video, before once we get to the packager, we encrypt the video using some keys that we get from the DRM server. Then when user device want to watch, okay, we download the content. The content is encrypted, okay, and then when you want to get the license, you go through the DRM server to our system, get the key in a secure way, okay, and it depends which device is it, and then the user can start watching the content. So this is in high level how DRM works, and take into consideration that this stuff is already on your devices, just need to read the specs, the API, and of course there are solutions out there to make it more simple. So this is regarding security. Another thing about ads, okay, ads are very popular today, and ads are not like 5 or 10 seconds like it used to be in the past. Video ads can be much more um, like a real short movie. And you need to consider them as a first-class citizen and take into consideration that sometimes you have like a very long ad. Sometimes you need to play the ad. Okay, you need to change your player to play now an ad and think about when you should start buffering it, when you should start watch it. So let's. I have a short ad, but let's look at the time. Let's keep on that for now. So how to deliver ads? So again, multiple players. You should have multiple players and think about like dual buffer, when to load the ad. There is also possibility to stitch the ad to the stream, meaning then the packager actually, or even the transcoder actually get the ads, okay, and stitch it to the stream. And I'll show it and I'll explain it a little bit. And make sure the ad will be adaptive too. Okay, so if your video is on adaptive streaming, we need to make sure also the ads, so you'll get the same quality and same experience. So how do we stitch ad to stream? Okay, and sure, you should remember that when you're serving ads to customers, it needs to be, of course, targeted ads. Okay, so when we get the stream from the packager, we actually do the ad request to the network, okay, to Google or any other ad provider per user, okay. When user we actually take the ad from the network, and then we stitch it to the HLS stream, okay. So instead of getting now the content, you will get an ad, okay. And the client need to be smart here, of course, to make sure the user will know it's now playing an ad, and if there is some click-through, or you want to know more about the ad, you should able to do it. You should be able to do it, and this is like the magic around the ads from the server. Let's talk a little bit about live. What are the challenges around live streaming of content? So the first one is, of course, the latency. When you're watching some sport game or soccer game, you don't want to hear your neighbor screaming goal while you still don't see the goal, or you don't want to get a push notification before that. So there is a lot of work going on in this area, and there is some new specs for HLS and Dash regarding latency and how to, for example, start playing a chunk where it's still not finished the transcoding and stuff like that. Very interesting reading to do. Another thing about live is that gives the ability for user to start over the show, okay, to restart the show, and maybe catch up some content that was in the past. And this is require you actually to save all the data that you transcoded already on package and make sure you have a good API to get into this content. And also time sync. So if you want to play a few streams, for example, from the soccer field, to stream the coach, to stream a different angle of the game, you need to make sure they are synced, and this is also a challenge you have around playing live streams. Something you should think about. You can take this use case also for, of course, a gambling, okay, or a live gaming or something like that. Same use cases, same challenges, okay, they're treated the same. Another thing, of course, is to talk about the big screen TVs, TV you have at home, and what do you need to consider when streaming video to this big screen. So, first of all, today, most of us consume the premium video on the big screen TV, usually not on the mobile and other devices. So a few things we need to take into consideration while building something for the big screen TV. First of all, we have some smart TV, for example, LG and Samsung and all of that. They have their own app store and usually based on HTML5. But the video is not acting the same as HTML, other HTML device like your desktop. Okay, it's not the latest Chrome or latest Safari or latest Opera that is installed in this machine. So you need to take into consideration something may not work, like captions or live streaming with ads or pushing ads to the stream itself. And this is something need to be verified. And there is, of course, the set-top boxes. Some of them are HTML5 based, some of them are Android TV based, and also need to build an application that will be controlled from a remote control. Okay, need to think about focus management and other shortcut from the remote control. It's not like a touch device and it's not a mouse. Okay, you need to remember who is your user and how to make sure he will be happy. So let's watch a quick video about that, about what it means to build in a big screen TV. Okay, so we should take, of course, all of this into consideration when building something for the TV, so user can actually enjoy all he can also likely enjoy from the mobile. Another thing we should think about the big screen TV is casting. Okay, you can cast a video to your big screen TV, so AirPlay and Chromecast and Google Home and all of that, you need to be able to connect it to your TV. 360 and VR, it's also something that today is supported on most of the devices we are using. So if we talk about, for example, watching video in your VR headset from your mobile, we have a lot of SDK for that, also on the web, on the HTML5 itself, and also, of course, from the other devices. HTML5 video, so we have the media source extension today. Okay, so if you want to play progressive download, all the devices can play it. But if you want to play HLS and Dash and HTTP streaming, today modern browser give you the ability and API to actually get the stream, add it to the buffer, and control everything from that side. And on that point, I want actually to move to some open source project that you should know if you want to start handling a video. Okay, so ExoPlayer is being maintained by Google, and this is actually the way to play adaptive streaming video on any Android device. Okay, all the big companies are using that. It's very common and works great. HLSJS is actually managed by the community, and it's giving you the ability to play HLS, HTTP live streaming on browser, what we saw MTU8, for example, browsers and smart TV and any HTML5 device. Shaka Player, also maintained by Google, is the way to play Dash streaming. Okay, it's like HLS, but a different type of protocol. Nginx VOD module being maintained by developed and maintained by Kaltura is the ability to use Nginx to server to actually produce HLS, Dash, and all of these ways to stream um, video. Dash.js is also like Shaka to play Dash stream over the internet, over HTML5 devices. And PlayKit is a player that actually wrapped everything for you, including DRM and all of that. It's maintained by Kaltura, and you can go to GitHub, just look through it, and it's a player both for Android. You have PlayKit Android, you have PlayKit iOS, and PlayKit HTML5 in order to play the content over there. Okay. I will run a little bit more faster, so we'll leave time for questions. If you want to think about some optimization you want to do on a stream, so you need to look usually at the segment side, the starting bitrate, choosing the right bitrate later, okay, start from the high bitrate or low bitrate or stuff like that. You should try to prefetch as much as you can from the stream in order to make sure that when user will start watching the video, he will the join time will be as low as possible. And of course, I think always about the network layer. Okay, make sure you are connected to the right edge in your CDN. Maybe warm up the connection if you can. Already close the HTTPS connection and the DNS lookup and all of that. This stuff can actually bring you from this is an example, a join time that we had with one of the customer, and all the modification we did around the network in order to improve it. Okay, and when we say network, again, it's the DNS connection that can sometimes take time from the device itself, the secure connection. Okay, this is like real example from the real world. And of course, always monitor and track your video state. There are companies that help you to do that. What is your buffer rate? How many failures you have? What is the join time to make sure you know how your customers actually experience their video. Yeah, so we'll talk about that, and also something nice that you can use also AI to predict what user will want to see, of course, using a recommendation and stuff like that, and already push the content to his device in a smart way. So when he will come and want to watch the video, at least the first segment or the first data will be on this device, and he will be able to enjoy it faster. That's it.